Saxon's Trig, Lesson 37, the line as a locus, and the midpoint formula begin on page 262. They start here with a review of things that we just talked about in some fairly recent lessons, which is how we got the Pythagorean theorem, showing the triangle with the set of boxes off of it. So if this was a 4, you've got a 4 by 4. If this is a 3, you've got a 3 by 3. And then that would make this a 5 if you Pythagorean theoremed it. So a 5 by 5, and that is how we prove that squaring the 4, getting 16 boxes, squaring the 3, getting 9 boxes, gives you the 5 squared to 25 boxes, and that's how our Pythagorean theorem will work. And then we just did the distance formula, so that the distance equals, and it was the large square root of the x set squared and the y set squared. And then to find the distance between two dots, so if we had this dot and we're finding the distance between them, it's the same as the Pythagorean theorem to find the hypotenuse. So we needed to have a way to find how long the y distance is, and that was when we did y2 minus y1, and the same thing, x2 minus x1, giving you the x line distance. And then the overall square root is the distance formula. Okay, so why do they stop and review all of that? And that has to do with the definition of a line box that's coming near the bottom of page 263. But before they do that, they review one more time in example 1, write an expression for the distance between 4, 2, and xy. So we're going to do, since it wants the distance, we're going to do the distance formula, large square root, subtracting the x's and square it. And again, as I said in the last video, I'm going to start with the letter variable 1 and then minus the number 1 plus, and then the same with the y's. And since I started with this one, I want to make sure I start with the same one minus the 4. And so that is the distance formula. So now let's talk about locus. And it is a Latin word which means place. So in mathematics, we use that word locus to describe the location of mathematical points. So then they jump to that box, definition of a line. A line is the locus of all points in a plane that are equidistant from two specified points. So if I have a point here and a point here, no matter where I choose to connect, if that is the same distance every time, what I am creating between them is a line. And so a line is a locus, the same distance, series of points that would be between. So that's what their point is for this lesson. Now they move into the nitty-gritty. In example 2, page 264, it says, find the equation of a line that is equidistant from a point that is 4, 2. So I'm going to label this one 4, 2, and -2, -3. So let's label this one -2, -3. And it doesn't matter that that's nowhere near how it would look on a normal graph. I'm just labeling it for explanation's sake. Write the equation in slope-intercept form. So because there are different formulas for the equation of a line, but the key one that you know at the moment is y equals mx plus b, it's clarifying that that is the format it ultimately wants your answer in, because eventually you will be reminded what the other equations for a line are, whether that's new or review. You still want to know which format they want it in. Okay, so we are given two dots. We are looking for the equation for the line that is equidistant in between them everywhere I could possibly draw lines. So if you find the distance between this unknown dot, and let's call it xy, this distance should match the same as this distance. Oh, distance, now you're hearing my distance formula, okay? So this set of distance between these 2 points should equal the distance formula between these 2 points. And then if I solve and rearrange it, I can get it to the format that they're looking for. So that's why this works. So let's do between the xy and the 4, 2, the distance formula. So I'm going to start with the x1 minus the 4 squared plus, again, the y minus the 2 squared equals the square root. Now let's do this one to this one. Again, x minus negative 2. I'm going to go ahead and write that as plus 2. And then y minus negative 3. Again, I'm going to write that minus and negative as a positive. And now I've set the two equal together because this distance matches this distance. Whether it went to here or here, those are going to be the same. All right, now we're going to solve. If I square both sides, I remove the square roots. And then we do need to square or FOIL or distribute, depending on how you wish to call it, each of these out. So I'm going to do my shortcut of, and what this actually means is x minus 4 times x minus 4. So x times x gives me x squared. X times the negative 4 is negative 4x, and in my shortcut I double that to negative 8x for the middle term. And negative 4 times negative 4 is positive 16. Plus, again, I'm going to do y minus 2, multiplying with y minus 2. Y times y squared. Y times negative 2 is negative 2y, doubled to negative 4y. Negative 2 times negative 2 is positive 4. So you can see why using my shortcut and not writing those out becomes very helpful when I'm doing lots of them together. But if you still want to write them out because that feels more comfortable for you, that's absolutely fine. X plus 2 times x plus 2 means x squared. 2x doubled, 4x, 2 and 2, 4, plus y squared, 3y doubled to 6y, I'm running out of space here, plus 3 squared is 9. Okay, now I have an x squared and a y squared on both sides. So when I go to put things together, they have canceled themselves out and I no longer have to worry about them. Good, because I know I'm heading down to a formula that doesn't have any squares. So now I have a negative 8x, which I can combine with this 4x. And because this one's negative and I prefer addition, I'm going to move it over. It also fits the fact that x is on the right-hand side. So add 8x. So I get equals 12x on this side. So now I'm finished with that one and that one. I'm going to continue to slash just so I don't lose a piece. I know that I want my y on this side. So even though this is a negative and my instinct is to move it to the other side, I want the y's alone. So I'm going to move 6y over to join the negative 4, so that's minus 6, so negative 10y, and I'm going to slash those off because I've used them. And that leaves me with these numbers, 16 plus 4. I'm going to go ahead and add that together mentally, making 20. And then I'm going to move it to the other side. So I might just jot down that it's a minus 20 when I move it over here because I have my 4 and my 9 that I need to put together. 9 plus 4 is 13. 13 minus 20 is going to be negative 7. Yeah, okay. Then the final step to get the y alone is to divide every part by negative 10. And that leaves me y equals 12 over 10 reduces 6 over, so negative 6/5 x, and negative over negative makes positive, and 7/10 does not reduce in any way. Let me check that answer is what they're looking for. That was example 2, negative 6/5. Yep, okay, we are good on that example. Example 3. Find the equation of the line that is equidistant from these 2 points. So 0, negative 4, and 5, 2. Find the equation of the line, so I know I'm looking for an equation of a line. And if I mentally picture this without drawing it out, then here are my 2 dots that I would be labeling, and I know I've got this xy on the line. Write the equation in slope-intercept form. Again, it's going to clarify it once this format. So we're going to just repeat exactly what we just did. We know it's going to be a distance formula and a distance formula. So we're going to have x minus 0 squared plus y minus a negative 4 is plus 4 squared. Repeating now with the other one, so x minus 5 squared plus y minus 2 squared. Okay, that's the xy to this point, the xy to this point. We're going to solve. we're gonna lose the square roots by squaring, and then I'm gonna FOIL these out. So x times x is x squared. X times 0, I don't have a middle term. 0 times 0, don't have a number term, plus y squared, 4y doubled to 8y, 4 squared, 16, x squared, 5x doubled to negative 10x, negative 5 times negative 5, positive 25, y squared, negative 2y doubled, negative 4y, negative 2 times negative 2, positive 4. X squared is going to cancel with x squared. Y squared is going to cancel with y squared. I know I want my y's on this side, so I'm going to add 4y. 12y equals, and I'm going to minus 16 to get it over here to this side to join. I didn't have an x term over here, but I still have this negative 10x, and then 25 minus 16 is 9, plus 4, 13. Divide everybody by 12, y equals negative 10, I'm going to write it, over 12. That's going to reduce to 6x plus, and then even though that's improper, it's not reducing. So I'm just going to leave it in that format, and I've just checked, and that is what we're looking for example 2. Now, in part B, they shift gears to the midpoint formula. Midpoint is exactly as you're thinking. If I have a dot here and a dot here, the midpoint is the one that's halfway in between them. So halfway in between something is like finding its average. So how do we average something? We add up the two parts that we have and we divide them in half, and that gives us the middle point. So that's exactly how you find the midpoint. You're going to have two different points with an y1, goodness gracious, and x2, y2. So you're going to add the x's together, x1 plus x2, and divide it in half, and that'll give you this x value. And then if you do y1 plus y2 and divide it in half, that becomes this, in a parenthesis, this becomes your new midpoint coordinate. So I would definitely jot this down as the midpoint formula in my notes. But for now, let's go ahead to example 4. Find the coordinate of the point halfway between, and they provide negative 2, 6, and 4, negative 10. So we're going to add negative 2 plus 4 is 2, divided by 2, that'll be my x value. 6 and negative 10 adds together to negative 4, divided by 2, that'll be my y value. And then we just simplify that, and it becomes 1, negative 2, and there's my coordinate point for the midpoint.